first 5 questions ask you to determine the equation to the midline. So someone tell me what the midline is. What does the midline do?
Like the middle of the graph.
It's the middle, right? Yeah, it's the middle of the graph. You're absolutely right. So we know something about when we look at the midline, we should hopefully know what kind of function it is, whether it's a sine or a cosine function, just by identifying the midline. So here you can count. Let's see, there's 1, 2, 3, 4, 5, 6 units is how like the total height of my graph, the total range of my graph is 6 units. So half of 6 is 3. That means that my midline is going to be 3 units either way, right? So just looking at this, remember your midline equation is just a y equals. So this is y equals -1. This graph, this function actually starts on the midline. So what function is this? Well, it's a sine function because sine of x always starts on the midline. And then cosine of x, remember, cosine is usually like starts at 1. So the cosine function is usually above the midline unless that leading coefficient is negative and it has been reflected. So this is all you need for that. Okay. Does everyone feel like they can find the midline of a sine or a cosine? Okay. Next one is determine the amplitude. So someone tell me what amplitude means. Nope, that would be the maximum, but good.
Difference from the highest point or lowest point to the midline.
Yeah, it's the displacement from the midline, either above or below. And we know that it is always, amplitude is always what? It's always positive because it's distance. It's always going to be positive. So let's see. What kind of a graph is this? What kind of a function is this? Well, it starts above the midline. It's not starting on the midline. So we just said it's a what kind? Yeah, this is a cosine graph. So I think that the midline is right here. Would you guys agree? And so my amplitude looks like 4. So just determine the amplitude. You're just putting in a number there. Okay. If I put -4, is that okay? Like if I counted it down here, 1, 2, 3, is it okay to write my amplitude as -4? Why?
Because
yeah, amplitude is never negative. It's always positive. It's distance. Okay. And then the last one asks you to determine the period. And that's what we're going to talk about today. So I'm going to just write down some things that you know. So here's my midline. This is y equals 2. My graph is not starting on the midline, so I know that this is a cosine function, right? This is the cosine of x. And when I think about the period, when you think about the period, you're trying to decide how many cycles take place within 2 pi. So you're looking at the number of cycles in 2 pi. Why are we looking at the number of cycles in 2 pi? Why are we just seeing what can take place in a 2 pi rotation? What's all the way around the unit circle? Halfway is pi, 2 pi, all the way around. So that's why we're looking at 2 pi. So if I look at 2 pi, that's that red line right there. If I were to grab a highlighter, you guys see that this actually takes 4 pi to complete one cycle, right? It takes 4 pi. So determine the period of this. So how much of the graph takes place in 2 pi? How much of the graph is getting accomplished in 2 pi. And when I say how much of the graph, I'm talking about how much of the cycle. How much of the cycle is getting completed in a 2 pi? Half. So the period for this is 1/2. Let me find another one. Let me grab another one like that. Your delta math periods. So Will, this is just your 8.4. I'm trying to do one of each type. So it's not going to let me write on this, but let's look at this one. Make it nice and big. So midline is actually the x-axis, right? That's the split. This graph splits at the x-axis. So, so that means that this is a sine graph. So this is one complete cycle, meaning I start at 0, I go up to 3, down to -3, and come back to 0. This is one whole cycle of my sine function. How long does it take for that one whole cycle to happen? Yeah, it takes 4 pi for one cycle. So 4 pi for one cycle. So the question is, well, what is the period of this graph? And the period happens in every 2 pi, meaning how much of this function is graphed? How much of the function is graphed at 2 pi? Have I completed all of it? I've only completed the first half of it, right? So this also has a period of 1/2. Ella, will you jump up there and hit next question if you scroll up to the, if you go up to the top, it'll say somewhere around there. It'll give us an option for a new problem. Perfect. And then slide back up so we can look at it. Okay. So same kind of question, really. Here's our midline. So that's one cycle. One cycle. So how much is completed in a 2 pi? We're completing a whole cycle or just half of it? Half. So this is another 1/2. Are all the periods 1/2? Will you hit it again? Give us a new problem. Is anyone in the period like doing the last section of this? I did it the other day. I had like, okay, here's a better one. Here we go. Okay, so here's my midline. So the graph is not starting on the midline. That means it's what kind of a function? Yes, cosine. Cosine starts above. Good job. Sine is one that starts on. So let's see. How long does it take to complete one cycle? It takes 8 pi over 5 to complete one cycle. Okay, so when I think about how much is completed in a 2 pi, this is my frequency times my period, always has to equal 2 pi. Always. This is what your lesson is today. So if I were to multiply, I'm glad that we have one that's kind of lengthy like this. If I multiply both sides by my reciprocal, 5 over 8 pi, 2 pi will go in there 4 times. So my period is 5/4. My period is 5/4. Meaning that it takes, in 2 pi, I get 1, 2, 3, 4, 5/4 of my graph. Because here's one whole complete, right? 1, 2, 3, and 4/4, which is one whole complete cycle. So there's one extra fourth, 5/4. That's your lesson for today, periods. But I just wanted to show you guys what that looks like. So make sure that you've done at least the first 2 portions of that 8.4 warm up. You know what a midline is, and you know what the amplitude is. Yeah, 8.4 trig graph features.
What if we finish that? You want to finish that?
If you finished it, that's totally awesome. Then let's get started on the lesson. Who wants like 5 minutes to just do part 1 and 2 of that 8.4 trig functions? Let me look and see what grades we've got on that. How many of you guys have finished it already? Yeah, good. Lainey, Keegan, you just have that second part, amplitude. That should be really easy, right? Eli, the first part, midline. Do you feel okay with that? Okay. Does anybody have a question on how to find a midline? Yes? Okay. Let me do a couple of them with you.